Hello everyone and welcome to our session on Algebra 2. Today we are diving into an essential topic, Introduction to Logarithmic Functions. These functions are a cornerstone of advanced algebra, and by the end of this video you will exactly know why they are so useful. Okay, so what what exactly is a logarithm? Simply put, logarithms are the inverse of exponential functions. Just like subtraction undoes the addition, logarithms undo exponents, allowing us to solve the exponents. They are not just theoretical, they do have many real world problems, also real world applications. And today we will be converting the exponential logarithms and logarithms to the exponents both ways. Be ready for that. So now let's start working here. Before we move forward, let's look back. Recall that an exponential equation is written as a base to the power of an exponent equals a result. For example, in 2 to the 3 equals 8, there is a base. The base is 2, the exponent is 3, and the result is 8. How would we solve for the exponents if we only knew the base and the result? Think about that, and that's what we will try to keep on doing in this presentation. Now, that is exactly where logarithms come in. They let us solve for the exponent, for that specific exponent. The general form is log with the base a of x equals a y, where a is the base and the y is the exponent and x gives us the result. As I like to say, logarithms and exponents are really just two sides of the same coin. So uh, let's practice the conversion process. If we start with the exponential form a to the x equals b, we convert it to the logarithmic log with a, base a of b equals x. Remember these three rules. The base of the exponent becomes the base of the log. The result becomes the argument, and the exponent becomes the final result of your log equation. Now the exponent, okay. Now convert the logarithmic forms. This is your turn. Take a look at these three equations. 2 to the 3 equals 8. 5 to the 2 equals 25. And 10 to the 4 equals 10,000. Now pause the video for a while, take your time, convert these to the logarithmic form. Now let's go to the other way. If we start with the log with the base a of b equals c, how do we get back to the exponents? We rewrite it as a to the c equals b. Notice the pattern. The base of the log stays the base, the result of the log becomes your exponent, and the argument of the log becomes your final result. Make sense? Let's now test the reverse logic. Try converting these three. Log with the base 3 of 27 equals 3. Log with the base 4 of 64 equals 3. And log with base 7 of 49 equals 2. Take a moment, pause the video here and try it on your own. Now, logarithms also have some special properties that make messy calculations much easier. We have the product rule, where the log of a product becomes addition. Then there is a question. There's a quotient rule, where division turns into subtraction. Finally, the power rule, which is important. It allows us to bring an exponent down to the front as a multiplier. These are your shortcuts for solving complex problems. In the real world, you will see three common bases most often. Base 10 is so common that we often just write it as a log without any base shown. Base E, which is approximately 2.718, is called the natural logarithm. and written as ln. Finally, base 2 is very common in computer sciences and information theory. Okay. Now, real-world applications. Why do we learn all this? Logarithms help us measure things that grow or shrink at massive scales. Think of a Richter scale for earthquakes, the decibel scale for the sound, or the pH scale for acidity. They are also vital for compound interest in the finance and then even data compressions in the tech you use every single day. Keep these things in mind. Now let's do a quick knowledge check. Looking at the equations, 2 to the 3 equals 8. Which of these four options is the correct logarithmic equivalent? Take a second to think. If you choose B, you are correct. Pause it here, think why. Solve it on your journal or anywhere that you can look at later. Now, here are two more for the practice on the road. First, how do you convert 10 to the 4 equals 10,000? Take your time. We have the options. Solve it on your own and then think about what should be your result. Before solving the next one, you may pause and then start the second one, which represents the exponential form, and you are supposed again on the logarithmic to convert it to the exponential form. Practice both and keep practicing. To wrap things up, remember that logarithms are powerful tools that help us solve equations that would otherwise be impossible to handle. We will practice it in a few more questions. Keep practicing your conversions because next time we will dive even deeper into their properties and more complex applications. Does anyone have any final questions before we end for today? You can put your questions in the comments also if you want.